everyone. I'm Emma Collins from Intel.
Hi, I'm Johan Bergsten from Ericsson, and we're here today to show the Ericsson Cloud RAN demo. It's more focused on the power performance or power consumption and what we are doing with the ecosystem in reducing that needs going forward.
So as we all know, from a mobile data traffic perspective, traffic is just on the rise, and it's going to continue to rise over the next number of years. And so we need to create optimizations. We need to do our work to improve the performance per watt that we can get within the network. As comm service providers are working towards net zero goals, they've been asking their ecosystem partners to come up with solutions to help them achieve these goals.
A lot of the traffic, or a lot of the power consumption comes from the radio access or the radios that we find in the cell sites up in the towers all around you. And there is of course a lot of work done to reduce the power consumption with new technologies and with the latest type of hardware from or the radio hardware that we have. But that's not enough. Of course you need to do things in the core parts of the network as well, and that's where it comes into play with Intel and our partners like Red Hat as well. And there are 3 different areas that we focus on, and of course there's a hardware piece of it, there's a software piece of it, and in the end automations of all this and make that in real time, I would put it.
Yeah, from a hardware perspective, Ericsson have adopted the Intel's 4th generation Xeon scalable processor, and with that comes Intel vRAN Boost, which is a vRAN acceleration capability that, because that now is integrated into the CPU itself, it takes away the need for a dedicated vRAN Boost or RAN Boost acceleration separate card. And so with that comes a power saving in itself. From a software perspective, Ericsson they're also leveraging our C-state technologies, which enable them to dynamically change based on traffic and demand, being able to take advantage of sleep states, which are inbuilt into our CPUs. And obviously from an automation perspective, we're constantly working on how we can automate this based on traffic demand, and we're continuing to collaborate in this area.
If you look at the power consumption, and what the results that we can show in today is roughly a 20% reduction in power consumptions when it comes to in low traffic scenarios. In more high traffic, of course, obviously you need more power to more users and more capacity and throughput. But the most important thing is to keep the performance level at the same. You cannot degrade that, and it needs to be the same. That's obviously what our customers are telling us. But as Emma says, there are more things to come in the future. Of course, there are different ways of doing this. And with automation, of course, there are possibilities to adjust this a bit further and come down with the power consumption, which, as we started with, you cannot really increase power consumption when the traffic increases. You have to flatten the curve there.
So we're doing a lot of work with the ecosystem, as you can see, Ericsson, Intel, Red Hat. We've all collaborated on this project, and we've loads of other things to come.